This is a short presentation I had made to the IEA GEF committee. They were talking to the less developed countries, probably countries from Africa and other parts of Asia. So I was invited to speak and I wanted to talk about light electric vehicles, and that's what this presentation is. But I think this is adequate and short enough to explain the work on charging infrastructure. But like the title says, the focus here, the way it is described, is a small EV focused e-mobility program and the distributed charging infrastructure that has to go along with that. So that is primarily what we are doing, except for buses. So the slide looks like this. On the left hand side, you can see this will appear every time. All of the BIS standards which have been published are available at this website. Most of them are free. And the architecture at this time, this was in December, which I presented. At that time, we had just formulated the idea that there can be 4 different power levels, and these are the 4 power levels. There is a normal power level, which is the normal electricity distribution, something you can access without having to put your own transformer. That's the idea. Things might change, but that's the concept. So that would arrive at your house either as a single phase up to 7 kilowatts or 3 phase capable of delivering 22 kilowatts of power, and that can be used either for light electric vehicles or even to charge your cars which are parked there near somewhere. So these are distinctly 2 power levels, level 1 and level 2. And then we have high power, which is the typical DC fast charging as we know, the CCS and CHAdeMOS and GBT. And this new category which we recently developed, standards have been written for e-buses, going all the way up to very high power levels. And we had embarked on this battery swapping thing at that time. So while I wrote this presentation, we didn't have too much information, but we are now quite advanced. So this is the context. It remains the context. I don't need to emphasize too much. We have discussed a lot. Whatever we do, we have to deal with what exists in our country in terms of temperature and weather, the driving trips, and the type of vehicles we have, and the fact that public transportation is a large segment of the vehicle which we need to roll out in electric. This was to explain to people abroad what our program is like. But here I think we should pause a little bit and see these are not realistic numbers. They are kind of theoretical, but people seem to have achieved it. This is the highest, let us say, is possible to achieve with extreme chemistry variations in NMC. Perhaps you can go all the way up here. Not very sure whether it is cell level. And NCEA, there is a number in 2017 seems to have achieved this kind of numbers, but they are both with nickel, then manganese and cobalt. Here of course it's aluminium. This is actually, you can see it is in the actual thickness of the electrode itself. So in a sense you can see what material is required. When you come to solid state, the material requirement is kind of quite less. Here again we are looking at the NMC variant of solid state battery, and there is solid lithium. Well, solid in the sense it's a thin foil, but you know, in microns it will be like this, with the highest potential energy density, which is expected by 2025. LFP looks like this. There's iron and graphite, and that's what I see here. In any case, what it means is, when we are talking about charging, you see, we have not included comparison with LTO or other fast charging system. We don't know how fast this is going to charge. The recent thing is, the claim is about at the lab level up to 4 times 4C rate. So practically we are talking about charging at 1C, max 2C. And the charging arrangement we are talking about is kind of assuming that this is going to happen. So you have AC power, need not explain, that's a rather simple thing. But if it is DC, then the best we can achieve so far, and that's what we are aiming for in the way we are organizing our charging infrastructure, is practically 1C we are targeting. So you have, of course, this indicates the power, there is a communication, and there is this micro level, every microsecond kind of a communication to align the status of the battery and what power needs to be asked from this charging station, and charging station, which is a slave, would deliver whatever the BMS would request for. So that is the idea. But then people like Akshay Singhal and others are saying that they already have very fast charging battery systems. Then there is a complication. Then what we thought would be okay for these levels, the things would change. Maruti has an LTO battery. If they deploy it in the electric vehicles, the situation would change. So I think it's going to be a little bit difficult if we try to keep varying like that. So we could take a position: if people need higher charging power, they can move to the next one. If it is a light EV which requires a huge amount of power, please go and charge this place at the parking bay. And if it is a car which needs a very high power, you could go over here. Or if you have some kind of a crazy battery, then certainly go over here and charge it. So that's how it could be. But if you look at what is the charging system, there have been questions about charging technology, charging systems. Well, this is conductive charging we are talking about. That kind of limits what the dialogue is. So there is a cable or some kind of a connector which provides the power from this unit, which is a converter, and provides to the electric vehicle. There is a lot of handshake issues. There is a lot of communication. So that is what we need to talk about here. The flow of power and things people have figured out. There is a charge controller sitting in the electric vehicle behind here somewhere, let's say, and there is a station controller sitting behind here somewhere. And their interface is the key thing we have been talking about. CHAdeMO, CCS, GBT, Tesla, they all have different ways of handling this data communication. It is data communication. So the issues we are concerned right now are the inlet and the cable connectors. What kind of cable do you need? And then can you, some people say it is forbidden, plug and socket at the charger, this one here, can you unplug it there? So all of that. So this is what we continuously talk about. But the power comes from somewhere else, This is the dispenser. The power comes from the back end, from the grid. Now for that we will need to address a whole lot of things which we haven't really looked at. All the charging systems which we have, DC charging systems, have built-in controllers which can address all of that, but it's like, where does the other end of the wire go? We really still don't know. So those are issues we need to address. The complete system includes authorization, the credentials, tariff. Now tariff could change, various ways of doing it, time of day tariff according to schedules. And then there is this question of roaming, which just means that there are different jurisdictions people have, different businesses control certain areas, and they have acquired the customer and they don't want the customer to go elsewhere, but the customer really wants to go somewhere else. So then how do you deal with that issue? All of that. And then the grid is never, the grid assets are never sized to the capacity, because most of the time, 80% of the time, apparently the transformers are sitting quite idle. So why would they want to put up a 100% capacity transformer? They would size it a little bit low to economize, but that creates a problem. If everyone who's got an electric vehicle is going to charge at the same time, then we could see some parts of the local grid, that is the distribution end on the streets, may collapse, but nothing may happen to the grid. Still, this is an inconvenience. So there is a need to kind of make sure that things are under control. All happens through the communication, and this communication, interestingly, doesn't matter whether it's coming off a scooter, a small point here, or a bus. I don't really see why this data should look very different. In fact, we should not allow it to be different. So if you do that, then the grid support and all of these things can happen. Everything is about data. So that's the point about this slide, and we need to pay attention to this. It would be somewhat similar. Of course, the data sets may be different. There may be more data sets of a different kind if you're talking about battery swapping, but we need the backend. If we don't have a backend, it's really not going to work. So now this kind of architecture we have for the Indian charging systems. Let's say we can say there are 4 types of documentations required. As we go into the next slides, we can see that much of this has been covered, light EV. Just one option is left out there. We have covered power level 3 adequately. Power level 4, the documents have been written up and it is in the shelf for certain reason. Parking bay charging systems. It is actually just a downsized DC charging systems, but still that document needs to be written up. And since we are also introducing this parameter that since it is a parking bay, we cannot really distinguish between which vehicle is coming up. Like if can we say that we will not permit a GBT cable connector carrying vehicle or a CHAdeMO carrying cable because the Charin seems to have included India in their map somehow. So that is not really possible. Any kind of so what has happened is the panel number 3 has devised a system where any of these data communications happening between the vehicle and the charging system, it can be mapped to a single thing which is implemented through Bluetooth. But this has not been done. It is just still talk. It is a technology project, and this is one of the reasons why I have taken a stand. For all these new things we want to do, we will have to actually do the thing before we write the standards, or maybe do it together. You cannot just have a paper written, just somebody imagining it and expect things would happen. And that's certainly a stand I've taken. There's nothing much, which is the reality. We need to do that. So that is there. It happens in light EV battery swap also, because just that no one has written. Even in Taiwan, even in Taipei, where they have implemented this extensive charging station, swap station network, 2 lakh swaps happen every day, but there is no standard. They have some companies' internal documentation, it works, they're happy, and it goes on. There is no national standard. There is nothing, not even a connector defined for e-bus battery swapping. This is not possible to do these things without a technology project being associated with that, and companies participating, labs participating, BI supervising. It is not going to work otherwise. Now coming to the last one here, roaming and grid integration. Grid integration, fairly simple system. Where the power comes from, there must be communication to them, and we have to just tell them this is what we are going to do, and they can tell you what is permissible. It's a kind of a negotiation before every charging instance. If it is automated, it is microsecond communication, so that's not too difficult. The term roaming is more interesting. There has been reports published by GIZ. The CEEW has also published reports they're trying to figure out. So what it is I think in Europe is more important, because in US if it's all either Tesla or non-Tesla, they don't talk to each other. But in Europe they have tried to harmonize, but they still have 30 countries to deal with, and within that there will be several operators perhaps. Maybe they're over, it may not be country boundaries, but there are many operators and many countries. So these jurisdictions have to be managed through roaming. Do we really need to do all of that? Because in India it's just the rupee. There is just this one boundary. Even if there is an octroi and toll post, but those things are not really valid because now FASTag has kind of removed all of that. I really don't see how roaming is an important thing for us to implement. In my view, if you look at India as a map, which you can either scale down and see, or like on your telephone, you can you can enlarge the Google map and see your house, or you can reduce it and see the entire country. That's a way. You locate your charge point there, and it's as simple as that, because the rest of the communication, we do data transactions every day with our credit card, debit cards, and UPI. Those things will be utilized anyway. And authentication, we all have an identity of some kind, Aadhaar and all of that. A vehicle has an identity. So what is left is a location of the charging station, and that means where exactly did the transaction happen. So this is a map-based information. I think we should be able to do that ourselves. But again, it is not just a theoretical thing. It really needs to be done. There needs to be a project for that. So if we can do all of that, then this handbook which the WRI brought out, and very encouragingly there have been more such reports coming out from Delhi government, from Karnataka. So these kind of local governance guidance documents, they will help the local electricity, let's say ADM sitting in an electricity office. He will know what to do with the application. or the person in charge of giving a license to the roadside kiosk, and everybody's got a license. Even the panwala has to have a license. So that person will know, okay, this electric vehicle charging station needs to be licensed, and these are the terms, this is what they're going to put up. So all of that. So this guidance to the local authorities, local governance agencies, the mayor's office, that will do the trick then, provided we have the back end in shape. This roaming and things like that, you cannot tell the mayor that there is something roaming around. So well, he'll say the vehicle is roaming around anyway, so what other thing is roaming? So these things we cannot comprehend. We want it very simple, and we want it implemented in this manner, extremely simple manner. It should be predictable. It should be everybody should be able to comprehend what it's about. So this is a little bit more about, you can see this document. It's one of the earliest ones which came out, which had given an emphasis to the distributed charging infrastructure. So coming to Indian standards now. See, the top table here describes what it is about, the BIS number, and the cost of it. Many of them are zero because BIS has decided that they will not charge for many of these documents. In fact, the prices you will find only for those documents which were published earlier, 2019, before 2019. I think they took a decision in 2019 to give it all away free, so all the later ones you will find is free. All these documents are available from this site here. On the left hand side you can see https standards BIS bsbeh.com. So that's the site. Keep a look for it and you can get all these documents from there. Now the structure is like this. This is a key set of standards which you will need to implement most of the charging systems. The charging systems itself is described in part 1. It actually also talks about what other documents are there in the series. It is like a index, it is like the hygiene factor. It tells you what is the basic stuff required. So there it says every charging system, every conductive charging system you are looking at today in the country has a basic communication that needs to be established. If it is AC charging, that should be enough. You can manage with just this basic communication. So what it does, it's about starting of charging. When can you start the charging? And what do you do when you have an emergency shutdown? So all of that is, and before you start charging there is a handshake involved. So that is about this basic communication. It's easy to say this is the analog communication required for any charging system, even DC charging, you need to have that. But in DC charging you have this issue that the charger is sitting outside of the vehicle and the power coming from the charger has to be controlled. That control sits with the BMS because BMS is intimately understanding what is the status of batteries preparedness to take the energy, because if you cross that you're going to increase the internal resistance. After all, it's about ions moving from one electron to the other and you cannot really push it. You're trying to reach the optimum. So for that you need to control the amount of power that is coming in and actually which cell it's going to. That's a different purpose the BMS is used for. So all that is done through data communications, and that is a big thing about DC charging. There is intense data communication, and the method of data communication is what constitutes separate charging systems. And to have that data communicate in a particular way, you need a particular connection system. Well, after all, in the DC there is only two big plugs sitting, the two big pins which provides the DC power, but then there are so many other pins, like there are 9 other pins in the CHAdeMO. Fortunately in the CCS there are only 3 more, but they are the communication pins and they define, in fact the shape of the connector itself now becomes a different thing. The CCS and Tesla are actually having the same connector. They made the pin looks different, shape is different. So the US CCS1 and the CCS in Europe is very different, just the shape, but they're all the same. They kind of, so this is about data communication. Although connectors are kind of specified for AC charging, there you can have a little bit more freedom if you want to, but better go with whatever is internationally available, because it's a two-way transaction. We can start manufacturing, giving out as well. So the connection system, which is so much in the conversation now, is described in fairly good detail, because it is a thing out on the road. A car can drive over it, it can be thrown on the floor, or it can be snipped and people can take it away, or people can just pull it out, all kinds of things. So we need to address that. So the technical term for this is plugs and socket is not the vehicle side, it is the charger side. You could use a plug and socket to unplug the cable from the charger if it is within reasonable power limits, which is as per standards up to 22 kilowatts of power. You can pull it out and put it back if you want. And this end, the very important end of the vehicle connector and vehicle inlet. So as you know it. Now coming to light TV, we have this light TV AC charge point. The standards number is this. This has been talked about. We intended that this should become a very common thing, commonly available installation everywhere. Hopefully the material cost should be about 4,000 rupees. That's the intent. And then it uses Bluetooth, and basically the communication is between the mobile here. On the right hand side you can see the picture, and the unit over here over Bluetooth, and the power would flow. So this connector does not have the ability to lock it physically, so you can pull it out. But there are ways. If you pull it out, of course, since authentication happens from the mobile, and it is a mobile wallet with a back end which is supposed to be controlling the whole thing, you can control it like you do with Ola and Uber systems. The whole thing happens over mobile. The power of the mobile is amazing, that Ola and Uber is actually using just the mobile phone's capabilities, and there is nothing else out there. It is the location is given by the mobile phone, the communication is given by the mobile phone, the computing power, everything. So that's what we are looking at. Can we use more of this? Now there is also a DC charging standard which is published practically for the first time in India, although the draft has come from abroad. It has come from Japan, and it is quite similar to the CHAdeMO, and it's a draft which is now with the IEC going to become an international standard, but not yet there. But we have taken that draft, cleaned it up and published it here. So we have a DC charging system for light electric vehicles. Now that is not making people happy, because this DC charge point and its connector is not to be found anywhere. Someone says there is someone in Taiwan who's making that connector, and that's not making people happy. Whereas if you look at the country's existing practices, Aether for example has a combined connector, others have experimented. So unless this really comes in, it is going to be a uncertain situation. People are not going to adopt it. AC charge points are getting adopted, but DC I think will happen in an extensive manner once this combined connector comes in. We have got a draft. It was said draft expected in December, but now we've got a draft. I think we will have this soon enough. That's about the light TV. The very important issue is being able to enable the citizens to help themselves, have the intent of the government guidelines of distributed charging infrastructure, employment generation, preparing the electricity utilities to manage their system in consonance with the charging requirement. That entire thing, which is actually smart charging, it can happen only at the parking bay. It cannot really happen at the DC charging station, this one over here, because although the DC charging station has all the capabilities required for smart charging, it is about our behavior. When we go to a DC charging station, we want to top up fast and get away from there, because that is not a place where I want to really be. I am going somewhere else, and the shortest time possible, you be at the DC charging station, charge and get out. There is just no scope, because of our behavior, or because of our attitude to how we look at the DC charging station, to use any of that smart charging function. Whereas if it is a car parked in the car park, car or any vehicle, and you left it there. So this is called destination charging because you have reached where you wanted to reach, and now you don't have much use for that vehicle till you want to go somewhere else. So the vehicle is lying plugged in the car park. That is a time smart charging is possible. Transactions of various kinds are possible, and this is going to help the grid. And see, if there is something which is helping the grid, they would obviously say please put more of that. So this is a very virtuous cycle which we can establish, and I think the Delhi government has caught it very well. Looks like Bangalore as well. They're encouraging a lot. Hopefully they're hoping that smart charging would be possible. They will be able to control or at least understand the charging behavior through some communications. So that is the expectation basically from the parking bay charging system. Now, how does this become a business? We are not talking about domestic charging. It becomes a business because we are expecting the current practice of managed parking lots to transit towards charging the parking bays equipped with charging. So what it would be, we expect these would be smart plugs at each of the parking bay, and they have connected to some system within the thing. There must be some kind of cabled arrangement. So essentially there is one power line arriving there, transformer, no transformer depending on what's required, and there is a modem arriving there, and then it is shared among all those smart plugs in each of the parking lots. And these smart plugs, they would operate on Bluetooth, the data communication, and they should be able to address any vehicle which arrives there, provided you of course programmed it. Now that single power line we are having in the parking lot could be 150 or less than that, depending on the parking campus. We expect the sizing should be about a dozen cars or something like that. Scooters, many number, but that's the kind of power we look at. And the other advantage is this is a place where a lot of other things can be integrated, like for example rooftop solar, and of course we talked about grid management capabilities. So it's a very important thing. Now I'm emphasizing, partly you can say I'm putting up this slide and talking to you to get this happen, because first of all this is first time in the world. It will not work for the kind of vehicles you have abroad, but it's ideally suited for the country, and we need to do a technology project. If we don't have the ability to do this kind of a project, then it won't happen, as simple as that. And you still will be stuck with these expensive charging stations, people going inside, all of that issues. You cannot get out of it. This is one way you can get out of it. So we need participation from industry to make this happen, and we will like to get a project commissioned and standards to be written. Standards are a very minor part of it, because after all this is the CCS in CHAdeMO, just a little bit adapted. So that is already existing. That is not a really big issue. It is about doing it and showing that this works, that the Bluetooth sitting inside a cable is not going to create an EMI EMC issue, or there are certain other kind of communication delay related or redundancies. Those have to be worked out. So it's a project to be done, fairly short project, but we need to do this. This is a very big thing which can happen from India, and it could become an international standard if it really works out, because there is already a joint working group 15 from the IEC trying to do this in a very heavy-handed manner. So we can show them what is frugally possible from India. Now this last category happened because we had Dr. Sumantran willing to spend his time and lead the whole effort. Now please recall that Akshay Singhal talked about a scooter requiring 300 ampere of power, which is pretty large, and then our charging systems will not be able to accommodate it. He will have to use a truck charger for that, which is a DC by GBT, and I think that's what he's going to do. Now what happens if a bus is going to have a heavy fast charging requirement? Then you will need either a pantograph, or maybe this system you have here, the dual gun charging system. So in order to prepare for that, in order to prepare for bus systems which are going to be bigger perhaps with a large battery, or something which absorbs power much faster, we have created these standards. So before I jump in, this top one here from 11 to 19 are basically the regular DC charging system, that is the fast chargers as we know it. You can see only two charge. Actually, the entire charging system is described in 11. What is a DC charging station? The annexures to this standard, that is the standard number 23, it describes what is CHAdeMO, what is GBT, what is CCS. It's in that order. It is A, B, C systems. It is called System A, System B, System C. C is CCS. Then there is another standard called the DC connector standard with 3 annexures which describe each of these vehicle end connectors for those 3 systems. After that you have from 13 to 19 all communication standards, and that's the key thing out there. These communication standards can be utilized for the next set from 20 to 21. Of course the systems become different now. They're much more capable. In dual gun we are talking about this one here, part 11, 23, doubled, the 2 of them. So we are trying to give this number 23-2. It's a nice way to know what that is. Then there is a new thing called the automated pantograph. So in the interest of interoperability in India, we have deliberately chosen only one way that the pantograph will come down from the pole. It could be the other way, or it could be a side mounted thing, but we have avoided all of that deliberately. It's a conscious decision so that interoperability is possible. Any bus can go to any charging booth with this kind of an arrangement and charge. So that's the idea. In terms of the dual gun charging also, we try to do that, but it seems some people want to go with GBT, so they let that argument come up, and if they can convince the Niti Aayog to change the current policy, that can also happen. But still there will be only 2 methods because CHAdeMO is not suitable at these high power levels. So currently it is a DCS with these 2 big pins, or it could be the GBT with a similarly large pin out there. There is also something to be talked about AC charging at high power levels. That single connector out there, the type 2, is capable of even 43 kilowatts of power, which the BYD is using. The issue of light EV battery swap, I think we will have to consider this as a separate topic. The other system was charging systems, still here. The job is done, all the drafts are there. The dual gun draft has to be worked upon further. 21 and 22, the drafts are final. So except for this, there is not much to be done. So we can say that we can wind up the things in charging systems, provided we get a team to work with the parking bay destination charger solutions. It's a technology project. If you do that, then the charging systems are adequate for the country. We have done it all. Now we come to the battery swapping. It's all about interoperability. So to make it interoperable, you need to define, of course, the pack dimensions and what is a charging battery swap system in general. Many things have to be defined out there. The pack is a self-contained entity. It is a very beautiful thing that it's got its BMS on it. It's like a different box, but it's completely independent. It connects, talks to the outside world. It charges and discharges only through that particular connection system, which is used to dock it wherever it's going to be put. So that connection system has to be decided what that is. If there are different kinds, then there is incompatibility. So preferably it should be only one. Communication protocol, there is just no reason why it has to differ. It is only data. You can decide to have it in one way, like everybody having an official language. That's what it is, just one method of communicating. It's very easy to implement. In fact, it's very easy to implement the back end if people just have to agree. So meeting of minds is the key issue in 27 and 28. 25 and 26 also looks at the chemistry, the energy possible. We are looking at a minimum of 1 kilowatt power available from a pack, and that pack should be light enough to be lifted. So 10 kilograms of pack size is one limit, and then 1 kilowatt hour minimum energy requirement. Now if you put it together, there is only a few variations possible about the pack, and you have to also decide, do you want it to, like the pack should be any which way you want to put it, like 360 degrees rotation, or you want it 180 kind of possibility, you could put it this way or that way, or you are willing that you can just put it one way. So three different kinds of connection systems have been proposed. We are evaluating that. But evaluation is just evaluation. Writing the standard is also that, but there is a need to validate. These things have to be done. These have not been done anywhere in the world, and it needs to be validated. Whether it is risky or not is a different matter. That is not the real issue. People may not get electrocuted through battery swap systems, but it is an unproven thing still. So there is a need for people to get together and prove it. We could write and publish the standard right away, but this effort for validation in our country is required, and it is even more so when you come to the next one. Much more. And here there have been successful experiments. A couple of companies have done it, but joined hands and done it. But systems are not worked out yet. Even this thing called a battery connection system, which they used, that is not in production anymore. We need to design it appropriately. A whole lot of things needs to be done here. But if you can do this first one, light EV battery swap, it kind of cleans out the methodology of how to handle a battery pack. And now we need to deal with systems which are larger, but the basic principles get established in the first one. So I think that should be what that should conclude what we are discussing. Thank you very much. Must have been a long talk.